Good morning and welcome to another Vibrant Technologies MEscope webinar. Today we are talking about video ODS, and this is a start of a series that we're going to be doing of some more tutorial type webinars. So we will, starting off with a video ODS that I believe we're actually going to do a part 2 of this type of webinar as well. So we may not get to everybody's questions today, but we will probably cover everything within a couple webinars. My name is Mark Richardson, Marketing Manager with Vibrant, and I'm joined by my dad, CEO of Vibrant Technologies, also Mark Senior Richardson, and my brother, Sean Richardson, who is our Director of Special Projects. And so both my dad and Sean will be doing the webinar today. A couple of housekeeping notes as we're going along. We are recording this video, so we'll get this out on our YouTube page here probably early part of next week. If you do have any questions, go ahead and type your questions into the dialog box there in the GoToWebinar panel on the right side of your screen, and we'll get those questions answered at the tail end of the webinar. Yeah, with that, let's go ahead and get started. We are going to talk a little bit about, just to kind of give you a summary here, we're going to go in, Sean's going to talk a little bit about camera setup. We'll talk a little bit about actually recording a video. We'll get into about how you do sampling rates, and then we're going to hand things over to Mark Senior, and he's going to talk about actually processing the video within the Video ODS wizard, and we'll kind of go through a few of the different steps in there. With that, let me hand things off. Sean, you want to get us started?
Perfect. Thanks, Mark. Yeah, so like Mark mentioned, in my part, I'm going to go through a lot of things that I guess come up commonly for questions for us, and things that sometimes aren't considered before we take these videos. But I think things are important, as we prepare to take the video, making sure that we're getting the quality that we want, because ultimately we want the the best animation on the back end of it, most accurate, most accurate data that we can derive from the video. So let's get into it. Set up, and specifically for this one, we'll talk about using the iPhone and some things that iPhone adds to videos that you don't necessarily need to use if you're using an Android or something like that. But we'll talk about how to get around that, a couple other things, and then I'll hand it over. All right. Okay, so within the iPhone specifically, there's multiple video options. When you actually go into your camera setting, as you slide across the bottom, there's two different video options. There's one that's video, and there's another one that's slow-mo. There's some other things in there too. If you have a newer phone, there's cinematic and some other things. But specifically the one that you would use for video ODS, we would just be using either the video or the slow-mo. And what comes along with those, if you're in the video tab, you get a couple different options. You get HD, and those come in 30 and 60 frames per second. And you get the 4K option, which is 24, 30, and 60 frames per second. If you slide over the slow-mo tab, it's HD only. You don't have a 4K option for slow-mo, but you can get to 120 and 240 FPS. So if we look at the video that's on here, you can kind of just see where it is. If you click at the top, that'll switch between 4K and HD. You can switch between the frames per second there. And then you slide over to the slow-mo tab. Same kind of thing, just change by selecting there. Everything's kind of touch. And again, Android has its own functionality. Different phones have their own functionality as far as how you get through. And there are phones that definitely do stuff with higher frames per second or higher frame rate. But for the iPhone specifically, which we're covering today, these are the options that are. Okay, things to consider here, as far as video quality and frames per second and how that ultimately applies to your video, your frequency span, you have a dynamic range of things that you can utilize when you're playing the video back and pulling data from it. The whole HD versus 4K debate. For HD, you're going to get 1920 by 1080 pixels. That's what you're going to get in the HD, whether you're zoomed in or not. Obviously, that's just the resolution rate. 4K is 4 times that, 4 times as many pixels, 3840 by 2160. If you simply look at them side by side, it's just crisp. It's a much sharper resolution. So if you are using something where you can get away with looking at low frequency, if you're talking about hertz, you're talking about 30 hertz and below, even probably lower than that, just to make sure that you fit everything within your video range. 4K is a really good option just because of the accuracy you're going to get, the video playback, the sharpness associated with the video. It's just a better option. But obviously, if you're doing anything rotating, reciprocating, you want to look at multiple orders, or you need to get up higher in frequency for whatever you're analyzing, try to determine modes or general ODS or whatever you're going to do. Sometimes you need a faster frame rate. And so ultimately, if you're going to do 120 or 240 frames per second, then you're going to need to use HD only, which is not bad, it's still fantastic, but it's just not 4K. Frames per second and how it applies to what you're using. If you're doing 30 FPS and you're using, rotating, reciprocating machinery, something that, you're looking at RPMs as your kind of benchmark, you're going to get up to 900 RPM of acquired range on there. And we'll kind of cover it as we get further into it. We have something called unaliasing, where if you are using rotating, reciprocating machinery and you're doing order tracking or multiples of the running speed, you can select the running speed, and then what it does is kind of unwraps the data. So it'll clean it up and it'll identify the different peaks at the multiples of the running speed. So instead of just 900 RPMs at 30 FPS, you actually have 1800 RPMs of viewable data there with the multiples. Obviously, the equivalent of that is 15 hertz, but without rotating and reciprocating machinery and knowing where the peaks are there based on multiples of the running speed, the unaliasing doesn't really work for you. But we'll talk about it later, but it is a good option. 60 frames per second, you get 1800 RPMs and 30 hertz. 120, it's obviously 3600 RPMs and 60 hertz, and then 240 FPS is double that at 7200 RPMs at 120 hertz. So again, things to consider when you're going in here before you take your video, just to make sure that you're going to cover everything. Just considerations. If you can deal with lower frequency stuff or have a lower running speed on a machine, and you can utilize 4K at 30 or 60 FPS, that's often a very good choice for you just because of the increased resolution. But again, if you need a higher frequency span in your data, then we got to go with HD at 120 or 240 FPS. Video time considerations. The video needs to be to get what you're looking for. Essentially, the way it works out, if you have 10 seconds of video, your resolution is going to be, every 6 RPMs or 1/10 of a hertz. And as it goes on, 15 is 4.5 RPMs, 20 seconds, 3 RPMs, and down to 0.05 of a hertz. Also, when you take longer data, I think it's something that we're going to cover in the second video of this series, which is averaging, and you can really clean up your signal when you have longer data, and you can utilize averaging to clean up your ultimate FFT, but you can get your resolution down even lower. So if you really need to get into it, do an in-depth analysis, and if you're closely coupled modes or things like that where you need great resolution to start picking things out, the longer video the better. Processing obviously takes longer with a longer video. That's just how it works with computers, but you will get that increased resolution. No different than you would use an accelerometer. Conceptually, it's exactly the same. Okay, so when we actually get into taking your video, a couple simple things. You can use landscape or just regular vertical alignment of your phone, depending on what you're needing in the video, what the structure is, what the machine is. In this example here that we have, we use this little, it's like a rotating trainer. It has a couple faults that you can induce, and so it's just a good way to test. But I'll play the video and you'll be able to see. Essentially what you want to do is you want to maximize the structure in the viewing window, just to make sure that you're covering as many as much of the part, of the machine, or you can zoom in on individual areas of the structure if you need to. Also, what it does is it helps eliminate any background motion, so you won't need to clean that stuff up out of there after the fact. Sometimes there's trees in the background, or if you have a piping system, associated with a compressor or something like that, a lot of times you're going to get cavitation in pipes, and you may not want that in the video. Again, in the second series, we'll talk about taking that out, which isn't a big deal. But if you can avoid it being in the data to start with, it's just easier. It's obviously, you can do things quicker through the wizard and get a much quicker result. But we want to maximize that structure in the viewing window. A big recommendation I would make, and you can get these on Amazon for cheap. I don't know, as low as about 20 bucks, and $50 or $60 they go up to there. But that would be a tripod with a cell phone mount. It's kind of just a clip that is spring loaded, and you just set your phone into there, but it'll give you the stability throughout the actual video. A lot of these will come with a Bluetooth trigger that so you can do non-touch altogether. I don't have one of those, but so I started and stopped it with the actual video record button. But once the phone and the tripod stabilizes itself again after that touch, it's very stable as the video is recording. And so what we'll do is clip off the front and the end of that video to the duration of the video that we want anyway, take it down to 10 seconds or so, and have everything in the middle so you get no movement from the actual touch of the start and stop. But I feel like tripod is a necessity, not an absolute requirement, but pretty darn close. You can see in this video here, just got it started, back out and kind of show that it's running there and filming, so you can see how it matches to the actual phone there itself and the screen. This point I was looking for about 10 seconds duration, so I believe I let it run to about 14 or 15 seconds. Go back in there and reach in and stop it. A little longer, I guess, 19 seconds, but go back there and stop it. And what that allows us to do is, once we get into the wizard, we can crop off, the front 3 seconds of it, maybe the back 6 seconds. We take it down to 10 seconds exactly. We get the resolution we want out of it and go from there. Okay, another thing that's unique to the iPhone is if you do use the slow-mo feature, which is going to get you to that 120 and 240 frames per second capabilities to handle higher running speeds or get you a higher frequency span. What it does is, in the iPhone, it creates a section in the middle of the video which really slows it down for slow motion playback. Obviously the higher frame rate allows it to have smooth playback, and so they take advantage of that by making it something that's just built in for the viewers. We actually want to get rid of that and just have a true straightforward playing 120 frames per second or 240 frames per second. And what I want to do is I'll go through this. I'll play the video and kind of talk about it at the same time, but you'll be able to see. But on this, anytime you get in the edit functionality, there's a little like 3-bar type thing at the bottom that you can press. And what that does is get you into the edit mode. Beneath the video itself, which is kind of showing all the frames, there's a slider bar or slow-mo bar at the bottom. Let me play this thing again so you can see along with it. What you'll see once you get that slow-mo bar in the middle is you'll see an exaggerated section where you can see where that slow-mo is set. If you grab the bar on the left side of that exaggerated section, you can drag it all the way to the right. What that does is take back the playback feature, or take out the playback feature that Apple has put in there for the phone viewing. And now you just have a pure 120 or 240 FPS video that is set up properly to import into MEscope at that point. So it's one thing that we need to make sure we do. It's a very common question is, my time doesn't sync up, or I'm not getting the resolution that I thought I was getting, or they thought they had 10 seconds of video and it comes into MEscope and it looks like 35 seconds of video. That's because if you don't take that slow-mo feature out of there, it just comes with the video as part of the MP4, and that's just what's going to happen. It's what's going to show up when you import it into MEscope. So when we take it out this way, we eliminate that feature. You're just going to get purely the length of the video that you actually recorded at a true 120 or 240 FPS without any exaggerated or filtered playback. When you're done with it, to save it, in the top right corner of the video, there's a done button. Click done. It's going to ask you if you want to save the video or if you want to save it as a new video. completely up to you. You can do whichever one you want. I just record over or save over the one I have because I don't need that artifact in there. But up to you what you're going to do on that. But at that point, it gets us ready to export. So usually files are far too big to text out of here or send an email. What we typically do here internally is we have a Google Drive that we share internally amongst ourselves within Vibrant employees. And so what I'll do is I'll just have the G Drive application on my phone. I'll transfer this video into the G Drive, and then it's viewable for everybody to utilize, or you can download it on your computer, or somebody, you know, one of our other coworkers can download it onto their computer. The other way to do it is simply to plug your phone into your computer, take the video off, and bring it onto your desktop or wherever you're going to use it, and go from there. So multiple options, but once we get to that point, you have your video set up at the frame rate you want for the duration you want, edited to make sure we take any of the different filtering options out of there, just a clean video we have, and we're pretty much ready to take it into the wizard at that point. And with that, I will stop sharing my screen and pass it over to my dad, and we'll go from there and get in the wizard.
All righty, let me hand it over here.
Okay.
There you
Show
go.
my screen. Okay, I'm going to bring up MEscope. You can see
There
this.
we go.
This
Yep.
is a little different than perhaps some of you who own MEscope VES, which stands for our visual engineering series. You can do video processing with an option to VES, which was originally designed for using accelerometer data or laser data, any other way that you took it or acquired the vibration other than videos. This is a separate program that we also sell that has a touchscreen interface. So it's more designed to be used in the field with your cell phone or any video camera where you can record the video and then bring it into this software and post-process it and look at the ODS in the time domain or in the frequency domain. So we're going to go through that. I'm going to take you through what we call the video wizard, which is the processing of a raw video to obtain the time waveforms and the DFTs, what we call discrete Fourier transform. And then we'll animate and deform a model, which is simply a point grid. It's a rectangular grid of points with frames of the video pasted onto that grid. So we use a lot of the technology that we already had in MEscope from years ago, where you build a 3D model and you link up your data to various points and directions on the model. That will all happen automatically in this application. So you can see I've got some recent projects over here that I could open that have already been processed, but I'm going to start off by processing a raw video. So this window here says open a raw video. It's got some other controls, brightness, contrast. I can exit and go back. Mark, do I need to hide? Yeah, let me hide that. Okay, so sorry, I had the controls on the right from the webinar on my screen. So now I'm just looking at MEscope videos. So we call this MEscope videos as opposed to MEscope VES with a video ODS option. So let me just open this. And here I have a number of videos stored on my system. You can see there are 9 unbalanced cases. So we took this little rotor kit, and we don't take videos in the real world. We're not a consulting company. We're just a software company. So we have lots of videos of these rotor kits. And let me just open one here. So there it is, the same one that Sean was showing you in his presentation. And you can see that we put different unbalanced screws here on the inboard and the outboard rotor. to artificially create unbalance in this machine. And then we can take the ODS data from the video and we can do further processing of the raw data we can curve fit it and get mode shapes and all kinds of things. So we're just going to do the simple stuff today. And the first thing I want to do is crop out a lot of the background because I'm only interested in the vibration of the machine itself. So let me just crop out everything that happened to be in the video that's not really part of my analysis. So there I've drawn a box, and you can see I kind of chopped off the top of the rotor. So let me do that again. I'll reset and do the crop over again. So again, we're just, as Sean showed in his presentation, this is a 60 FPS or 60 hertz sample rate video. Okay, so then I got everything in the picture here. And the raw frames have over 8,000 pixels in them, so an awful lot of data. It's amazing technology that your cell phone has in it. But you'll see in a minute, we're going to reduce this down to a data set that we can deal with. Okay, I can change brightness, I can change contrast. So let's just scroll this. If I'm taking a video in a dark room and I don't, the other advantage of the cell phone is that it automatically brightens up each frame of the video. So you don't need floodlights. Higher speed cameras may require it, but your cell phone can make very good videos, record very good videos. And then this is a contrast. So if you got some really dark stuff out of a corner of a room in a building, that's where the machine is setting, you can brighten things up. And that's just going to help the algorithm that processes the frames of this video, frame to frame to frame, and it looks at the difference in the coloration of a pixel from frame to frame to frame to actually extract the vibration signal. And there's a number of algorithms out there. We're using a commercial version that also uses the NVIDIA chips in your computer, and they're designed for handling videos and graphics processing of various kinds. My computer is 5 years old, so my chips are probably a little bit slower than what would be in a brand new computer. So keep that in mind if you're going to go out and purchase a new notebook computer to use in the field with your cell phone. The processing time will probably be a lot better than we're going to look at here. Now, as Sean was showing you, here in this page or this step of the wizard, if I had to stand on my head and take a video of a machine that was, I just couldn't get a video of it any other way except holding the camera at an angle, maybe even upside down, we can change the video, change all the frames of the video right here by 90 degrees and, get a picture that's going to make some sense when we process the data further. So these are just some controls. Here's our cropping, and this controls of brightness and contrast. That looks pretty good to me. So I'm just going to go ahead and go to the next step, and I'll hit the next button down here. Okay, what it's showing now is the first and the last frame of the video. So as Sean mentioned, we may have some jiggle because we touched the cell phone with our finger. This video was recorded with a Bluetooth remote switch button, and so all the frames are good, but I can change the frame count. So you can see I got almost 1,000 frames here, and it says 16 seconds. So if I multiply 60 FPS times 16, that's the number of frames in the video. And the algorithm is going to extract a time waveform for each frame or from each frame of the video. So I'm going to end up with a data block full of time data, sampled time data, just the same as if I'm acquiring data from an analog signal from accelerometers, multi-accelerometers or a single accelerometer. Each channel in a FFT analyzer will sample the data exactly the same as what we're doing here with a video. So my frame rate is set to 60. Here's where I can set it to 120, 240, whatever it was in the camera. And if I get this wrong, we'll see that the frequencies in the spectrum come out wrong. So I can always go back here and set it to a different frame rate if I didn't happen to write that down somewhere. And I've got some slide bars here. Now, the processing time for a video is really dependent mainly on the number of frames. So let's just go on here, and I'm going to go next, and we'll look at the rest of the steps. Now, here's something that's unique to MEscope, because we've had this capability since the beginning for looking at 3D models. This is a 2D model, and it's just a grid of points with surfaces, and then a frame of the video is pasted onto this rectangular point grid, and I can change the number of points. This will affect processing a little bit, but what it allows me to do is take let me just put it up here to 12,000 points. Remember, this video at 60 FPS out of an iPhone has 8 million pixels per frame. So what we do in MEscope is reduce that down to 12,000 points. Now we're going to have vertical and horizontal motion from each frame. So if I leave it on 12,000 points, I'm going to end up with 24,000 time waveforms and also 24,000 DFTs. Well, that's an awful lot of data to work with. It's fine if you want more accuracy, more data, and we'll talk about that in our advanced treatment. But if I'm interested in just the vibration at the top of these bearing blocks, which is typically where you would put accelerometers on a machine like this, or if you got bearing blocks from a motor and a pump combination, and refineries and process plants, power plants have thousands of motor pumps. And so that's a very common use of something like this. And what I would want to do if I want to compare the video results, and we'll get into that also in our follow-on series, I want to set my point grid so I get some good data at the top of, let's say, these bearing blocks, so I can compare that motion with accelerometer motion. We'll go through all that. Accelerometers are measuring acceleration. Videos are measuring actually displacement, frame to frame to frame. But we can differentiate that data and get velocities. We can integrate the acceleration data and get velocities and compare apples and apples. So now I'm going to go on and say extract the time waveform. So this is the basic processing, and you can see it's going to take 5 minutes. Rather than go through this and process this, I've already done it and I've got it saved away in a different project. But let's just go back and just play with this a little bit. And let's just say this is your first time ever trying out a video in this software. We can go all the way back to the beginning, and let's just take one of these rotors here, and let's just say we're really interested in that part of the machine. So I can go through and do a next, and here I'm going to cut my frames way down, and as Sean was saying, 10 seconds is plenty of data. There's 6.7. So if I increase this a little bit, let's just take 10 seconds of data. So, and then you can see that that's only half of the number of frames that are available. Plus I've got it cropped down quite a bit. So let's just go ahead and hit the next button. And we'll keep the same number of points. So we got a lot of resolution here, although I could drop it back if I'm just interested in, you know, a few points on this rotor. That's going to give me plenty of resolution, and let's extract the points. So you can see this takes less than a minute, 45 seconds. So let's just go through and process this one, and we'll look at what we get out of it. And then we'll go back and I have a project where I've spent the 5 minutes and processed the whole machine, the whole test article. Again, it depends on the problem you're trying to solve. This might be enough of a video so that you can focus on a problem in a machine. Maybe it's just a bearing block. Now we picked the rotor itself, which will be interesting because you can't sense the motion of a rotor. Now this step here is where we scale everything. And so we set a distance here. And I need to put in order to convert the motion that's been extracted from the video to actual engineering units. In this case, you can see I can set it to inches or feet or meters, whatever. But I've hit the set distance, and I'm just going to put a point there and a point there. And we've tested the accuracy of this with respect to accelerometers, where you need to scale the accelerometer and so forth. And so this process is going to scale my data. So all my time waveforms are going to be in inches. My DFTs will be in inches. I can easily convert to inches per second from here on. So we need to scale the data somehow. Now, the other way, if I don't trust the video itself, or I can't pick a distance like this, and it can be at an angle, it doesn't have to be horizontal or vertical. I can even put a yardstick in front of the test article, and then I know that that's 3 feet, and I could click on the ends of that in the video and then crop that out. Well, I would need it for this step, but let's just say, I don't know, let's just call it 4 inches or so, which is probably close. Okay. Now this is an interesting step here also. This is where the software has organized all of the points, maximum motion, and we call this a magnitude filter. So it's actually calculated the magnitude of the displacement at each point in the video. And so the smallest is bin number 1, and the largest is bin number 100. So this is like a histogram, and there's other words that you could use for it. But if I wanted to just get rid of, well, let's just leave it like this, because you can see that the first bin is the highest point count, and that's up to 28 or 2,300 points in this video. So we still got a lot of points here. But so I'm going to finish, and we'll just go through and look at the animation, and then we'll go back and try this a couple more times, just to get through the whole process of using the wizard. Okay, well, I got kind of a strange picture here. I've only got the top, so my cropping didn't work very well. Let me go back. I'm gonna cancel this, and no. And let's go back and get the raw video again and start over. That cropping didn't turn out the way I wanted it to. So let's just do another crop here. And we'll just grab a little more of the machine this time so we can see things really moving around. And okay, so here, let's just cut the frames down, and I can do it from either end. And let's just cut it down to 300 frames. That'll give us 6 seconds of data. And let's just go through and see how that looks. Okay, I got a point grid. I'll take that, whatever that is. And so this is going to take minute and a half. So you can see I can go back and forth, or I can just stop this. Let me go back and let me exit the wizard. And now let me just open the project that I processed that already has the full machine and the full 16 seconds of data. And that took about 5 minutes. So I can do a lot of processing. You can see it says original up here. So here is the original. You can see 16 seconds of data. Each sample of data in the time waveforms. These are the time waveforms. I got 1,200 and, well, at least that many, 63. So a lot of data, and the data is organized from the largest displacement to the smallest. Now it says displacement here. So apparently I didn't scale this data. Now I have a good way to measure along the base of the machine and so forth, but so we looked at that already. Let's just go and look at some of this data. Let me, where are we here? I'm going to open this and I'm going to put up a peak cursor. So let's just put the peak cursor. You can see that my controls are all right here on the screen. So I'm going to put it a peak cursor, and there is the largest order. Typically the running speed of the machine will be the largest order or the largest peak. And we got other peaks in here. But let's just crank the amplitude here and see what we have going on. Well, the pulley and the rotors are moving around quite a bit, but now when I crank the amplitude, you can see that the base plate, the base of the whole machine is just rocking on its rubber mounts on a tabletop where we made this video. So that's something you can get out of the video very easily. Let's go to this peak over here, and it says, you know, it's almost 2,000 RPM. And now the base is not moving, but if you look at these rotors, there is a mode shape right there. Clearly you can see the deformation of that rotor, and there's no other way you could measure that other than with a video. So a video is very useful for getting vibration on a machine. Let's go down to this rotor. Again, look at the, let me lower the amplitude a little bit. You can see that there's a higher frequency mode of vibration of that inboard rotor. Now the outboard has got the unbalanced screws in the picture, so that's why that looks a little crazy. But you can see things from these videos that you couldn't get any other way. Let's go over here and I'm going to put it back on the running speed. And now up here I have another command that says alias orders. So I'm going to turn that on. So here is an issue that you have to keep in mind when you sample at lower frequencies. Also, an FFT analyzer or a spectrum analyzer or a spectrum-based data acquisition system has what are called anti-aliasing filters on each of the channels, and they filter out the high frequencies. There is this hardware you can buy to put on the front of your phone and filter out the higher frequencies, but here there is no anti-aliasing filtering. So what we're seeing here are two of the higher orders that are aliased around half of the sample rate. Now the sample rate of a 60 FPS is 3,600 RPM, and half of that is 1,800 RPM. So you can see we're looking at RPM here. The running speed of the machine is about 1,000 RPM. If I put the cursor up here, there's the second order. and down here is the first order. And then of course we're seeing the ODS at that frequency. Now let me go and execute a different command in here that says unwrap the aliased orders. Well, let me put this back on the running speed, make sure we get that. And now we're going to unwrap the aliased orders. Okay, so here we are with our raw data showing, come on, where are you? Okay, well, we're seeing the one order. So now I'm going to say show the aliased orders. Yeah, here's our raw data. This is the DFTs right off of the video, just a Fourier transform. And now I'm going to click on show the aliased order. So what it did is it unwrapped. Here's my running speed now at 1,000 RPM. Here's my second order at 2,000, and here's the third order at 3,000. So now I can go back and I'll accept that, and I can actually use this data. Now there could be other peaks, there could be resonances in the data, and of course at the orders there are resonances are participating. So as I showed you here, we can see the mode shape of these rotors right from the display of the various orders. So you can just see as I go up in frequency, that mode shape of that M board is really clear. And then I'll go up to the 3,000 RPM. So now you can see even more deformation. One side of the rotor deforming different than the other side. And we know for all machinery, all mechanical devices, now you can see the whole machine bouncing a mass on a spring, the vibrant logo, it's just bouncing on its rubber mounts at that low frequency. Okay, Mark, I'm pretty much done. Do we have any questions?
Nothing right now. If you have any questions, go ahead and get your questions typed there into the box, and we can get those answered. Sean, do you have anything you wanted to add?
No, I think we've got good basic coverage, kind of concepts you want to consider when you're getting ready to shoot, and you know, the initial steps of processing a video. Lots more good stuff in here that we'll be able to cover in the next one, and really kind of expanding the use of video ODS. But I felt like we got a good start, but happy to answer any questions now or via email or, you know, later or whatever works.
Yeah, if you got any questions after the webinar, you can always email us at sales@5tech.com, or if you have any questions about pricing, we'd be happy to answer those questions as well. All right, well, we must have done a good job. No questions. We can wrap it up there. Again, we're going to get this put out on our YouTube site, and we will get part 2 of this webinar going here in the next few weeks. So stay tuned to your email inbox, and we'll have an invitation out to you shortly. Great. We'll wrap it up there. Thanks, everybody, for joining us. Have a good afternoon. We'll talk to you later.
All right. So long.
So long.